Welcome back to the Basic Aeronautical Knowledge series. Right, today we're talking about height terminology we use in aviation, how we measure it, why pilots use different units, right, and what you need to know for your flight training. From above mean sea level to above ground level, these measurements are essential for vertical navigation and our flight altitudes. First, we need to understand above ground level, or AGL. This refers to the height of an aircraft or an object relative to the terrain or ground directly beneath it. This means that the height above ground level is always changing depending on the elevation of the land below. Pilots use references to their height above ground level to ensure safe separation from obstacles and terrain, especially during takeoff, landing, and low-level flying. For example, if an aircraft is flying at 2,500 feet above sea level, but the terrain below is at 1,800 feet above sea level, the aircraft is actually only 700 feet above the ground, right, which is its height above ground level. Above ground level is an important reference for pilots when avoiding obstacles, complying with minimum safe altitudes, and navigating visually. It is also the measurement used for cloud clearance requirements in visual flight rules, right? And this is why situational awareness and understanding terrain variations are critical when flying at lower altitudes. All right, let's discuss above mean sea level, or AMSL. All right, this refers to the altitude of an aircraft, terrain, or an obstacle measured from the mean sea level. Unlike height above ground level, which changes depending on the terrain below, AMSL is a fixed reference used across aviation for consistency in navigation and airspace management. This measurement is critical for aviation navigation. Pilots rely on AMSL for setting altitudes and planning routes. Airspace structure. Different airspace classifications and controlled airspace are defined in AMSL. Aerodrome elevation. Airports are assigned an elevation above sea level, which affects flight planning and instrument approaches. For example, if an airport has an elevation of 500 feet, AMSL, and an aircraft is flying at 3,000 feet, AMSL, the aircraft is actually 2,500 feet above the airport. However, if the terrain below the aircraft rises to 2,000 feet AMSL, then the aircraft is only 1,000 feet above the ground. Understanding AMSL is essential for maintaining safe altitudes, complying with airspace regulations, and ensuring accurate altitude settings during flight. Unlike AGL, which varies with terrain, AMSL is a stable reference for pilots worldwide. As we know, height is always measured in feet, but there are different ways to reference it depending on what we are measuring. Now, we use three main terms. Elevation, this is the height of a specific location on the Earth's surface, such as an airport or a mountain, measured above mean sea level. For example, if an airport is located at 500 feet elevation, that means it sits 500 feet above sea level. Height. This refers to the height of an aircraft or an object above the terrain directly beneath it. And this measurement is always changing as the aircraft flies over different elevations. Pilots use this when considering obstacle clearance and safe landing approaches. Altitude. This is the height of an aircraft above mean sea level. Altitude is the standard reference used in aviation for navigation, air traffic control, and compliance with airspace regulations. Let's break it down with an example. Imagine an aircraft flying at 3,000 feet altitude above mean sea level. If the terrain below the aircraft is at 1,500 feet elevation, the aircraft's height above the ground is 1,500 feet. But if the aircraft flies over a mountain that rises to 2,500 feet elevation, then it is only 500 feet above the ground at that moment. Elevation is the height of a specific point on the Earth's surface measured above mean sea level. Unlike height above ground level, which changes depending on terrain, elevation is a fixed measurement used for reference in aviation. We typically use elevation for two main purposes. Aerodromes, every airport has an assigned elevation, which is the highest point on its usable runways above mean sea level. This is essential for pilots when setting their altimeters before takeoff and landing. Right, for example, if an airport has an elevation of 104 feet, this means its highest point is 104 feet above sea level. Pilots can find this information in aerodrome charts and publications like the En route Supplement Australia. Terrain, mountains, hills, and other landscape features also have elevations measured above mean sea level. And this information is crucial for navigation and obstacle clearance. For example, if a peak is marked at 3,500 feet, pilots must ensure they fly at a safe altitude above it. Terrain elevation is commonly found on topographical charts. Understanding elevation is key to ensuring safe flight operations, as it helps pilots determine altitude settings, avoid obstacles, and comply with airspace requirements. Altitude is a key measurement in aviation, referring to the vertical distance of an aircraft, terrain, or object above mean sea level. Below 10,000 feet, we use altitudes based on the local air pressure setting, known as QNH. This ensures that all aircraft in a given area are using the same reference point for altitude. In this image, we see an aircraft altimeter indicating approximately 3,000 feet above mean sea level. The altimeter works by measuring atmospheric pressure and converting it into a height reading. Understanding altitude is essential for navigation, compliance with airspace rules, and maintaining safe separation from other aircraft and terrain. By setting the correct QNH, pilots ensure they are flying at the correct altitude relative to airspace requirements and minimum safe altitudes.